Hello, thanks a lot to the organizers for the opportunity for both of us, I think, to be able to talk. I'm going to start with the clinical part, and then I'll hand over for the fancy stuff at Raphael. And just so to get an impression of the crowd, the physicians are not allowed to vote, but for the rest of you, how many of you had heard the word sepsis before looking at the program today or listening to Olga's talk? Can you raise a hand? Okay, so we have a good crowd, so then I'll just leave it up to you to take the... I'm kidding. I'm still going to try to tell you what sepsis is. Sepsis is essentially an infection, whether on your skin, lungs, urinary tract, or somewhere else, that triggers a life-threatening infection. And to try and to illustrate how important it is, I'm just going to run you through a few numbers. It represents about 50 million cases per year on the planet. It has a 10 to 20% mortality rate. When you're going for its extreme form, septic shock, you're rather in the 40 to 50% mortality. So this is by no means something with which we joke around. And those that survive often have significant sequelae after their hospital stay. And then because physicians are usually keen to have pissing contests, you'll see that compared to other well-known diseases, heart attack and diabetes, sepsis is actually not that well known, but really responsible for a lot of of deaths around. Now, sepsis is challenging, and one of the major challenges in sepsis is trying to define it. It's this entity, infections, and the body that responds inadequately. You'll see that early on in antiquity, it was described essentially by the smell, the rotting aspect. Sepsis means putrescing matter. So those were dire prognoses. In the 1800s, one started talking about blood poisoning as one realized that bacteria were behind this phenomenon mostly. And it's not until 1992 that there was the first attempt to define this. And it was defined by that time as an infection as well as a systemic inflammatory response syndrome, qualified very loosely by 2 out of 4 components, how fast you breathe, how fast your heart rate goes, whether you have white blood cell changes, and whether you have a fever. The problem being with that is that if I have a cold and I run upstairs, I'm going to qualify for a sepsis because I'll be breathing fast and my heart will be beating quite fast. There was further attempts to refine, and I think this is something to which Olga, she's not there anymore, Olga alluded to with organ dysfunctions. That was consensus 2 definitions. And those definitions were coined around a single organ dysfunction. And by 2016, there was this notion that, well, SIRS criteria were problematic because not specific enough, and we need to get a better sense of this organ dysfunction. And so in 2016, there was the sequential organ failure assessment score, SOFA score, or sepsis-related organ failure assessment score, which was introduced to try and better define patients undergoing sepsis. And essentially, this is a composite score of 6 organ functions: cardiovascular, respiratory, liver, coagulation, mental state, and kidney function. It's fairly arbitrarily chosen, but it's an easily operational definition that we use. It is, by definition, a melting pot of potentially different things, because it's a syndromic definition. And it's already recognized that we hope to have one day a sepsis consensus 4 definition where we'll be looking at endotypes, or apologies to the organizers, that was the pointer, where we hope to be able to break down into clearer entities the melting pot that we have. Because indeed the challenge is that when you look at these patients that undergo this dysfunctional response, you have a wide clinical presentation. Some patients may go into a immune overdrive. You may have heard of cytokine storms during COVID. Some patients, when you test their immune system, may actually be immunoparalyzed, have an immune system that doesn't work. And so this heterogeneity is already understandably difficult to class as one entity. It gets worse when you think of our patient groups. You know, a neonate, a preterm neonate has nothing to do with one of our patients in geriatrics. And take a post-surgery patient and compare it to a patient that's getting chemotherapy, you have an extremely broad presentation. And this is one really of the challenges, is this heterogeneity is hard for clinicians to recognize. And one of the key numbers that I'd like you to associate with sepsis is this one. Patients presenting to the ER that have sepsis are triaged as non-urgent in 30 to 50% of cases. Yet sepsis is an emergency. And this has been checked, or this has been observed in Europe. Those are the first and fourth, and in the US. So it's not some kind of lousy local performance, it's just a reality. And so, you know, the CHUV in Lausanne recognized improving sepsis care as a critical strategic decision and launched in 2019 a quality of care program. And so now, Rafael is actually going to show you what we've been doing on the data science side to try to assist clinicians with our struggles with sepsis.
Thank you, Sylvain. Okay, so indeed, now that you know what is sepsis and the fact that it's a very severe syndrome, I would like to show you what pipeline we have deployed at CHUV. So here you have the global overview, going directly from the data from the hospital to the dashboard, which will be delivered to the clinician, so they will be able to take targeted actions for the patients. So the first step, of course, is to collect the data. And currently, we are focusing on specific units. We are not enrolling all patients of all units because there is a program sepsis that has been deployed in these units, which consists in, like, each time a clinician has a sepsis suspicion, he will ask for a specific set of analyses. And thanks to this specific set of analyses, these cases will be reviewed and we will be able to have very important information, like first, the label. So we have 3 labels. Label 0, it's not a sepsis. Label 1, we don't know, it may be a sepsis, maybe we are lacking some data, or it's not possible to conclude. And the label 2 is, this is a confirmed sepsis. And of course, another information which is very, very important, the time point of the sepsis. So, of course, for all of these patients, we also have access to all the data, the lab, the vitals, medication, etc., and everything is gathered into a big data warehouse. Okay, so now you know how we collect the data, on what kind of patient we are focusing on, and so what do we do with the patient now? With this data, sorry. So all the data will be processed. First, as you may imagine, it's data from medication, not intensive care, but medication, labs, vitals. So we need to pre-process everything, homogenize, clean, everything. And so it will run over a bunch of scripts, and we will compute also a lot of clinical scores. As we have these scores, the first step was not to do some machine learning. The first step was, okay, now that we have all of that, let's build a first dashboard and display all this information for the clinicians. What you see is like just a sample of the dashboard that we have, and we can of course display a lot of scores. On the left, you see patient, what we call with block sepsis. Remembered, I said that when the clinician has a sepsis suspicion, they could ask for a standardized set of analyses. So on the left, it's all the patients with sepsis that went through this program. And on the right, this is patient that had sepsis and didn't went through this program. And so do not try to read all the results. I know it may be a bit obscure, but the fact is, we see now that people that went through the program tend to have the first shot of antibiotic sooner than the one that didn't. And this is very important because, as you can imagine, it's mainly due to bacteria, usually sepsis, so the first shot of antibiotics is critical. And of course, we are following different kind of metrics and everything that can be relevant for the clinicians. Okay, so now we have the data, we have the computation, we have the first dashboard. Now we can do some machine learning also because we have already all these scores. So what we can do is reuse all this data, and prepare it for to be used for machine learning models. And what we have developed, is an ensemble method composed of, for now, 2 models and a top layer model. This will allow us to have every 6 hours a prediction of sepsis probability for all of the patients in the current units. So with these results, we are able to display them into another dashboard. At the top left, you can see the sepsis probability for a specific patient. And you can see that we have a huge increase at a specific time point. And so it's going to tell to the clinician, OK, we are looking, because for now it's only a retrospective analysis. It's not for patients that are currently hospitalized. I would like to underline that. So it helps the clinicians to review the patients. Because it will tell them, okay, maybe you should have a look to this specific time window. And at the same time, we are giving them everything that they want to see. For example, the clinical scores, the ICD codes for the patient, and some general information. And as you can imagine, there is a lot of things if you scroll down. Okay, but this is machine learning. And for now, and we know that with the program which has been done, we have sepsis cases every day that are reviewed, which means that our dataset is growing and growing. So we could retrain the models, and this is what we are doing. So currently, everything is deployed and everything is running daily. And what you see at the left, at the top, is the performances, like the precision, recall, and F1 score of the ensemble method. And at the bottom, it's like the 2 models which compose this ensemble method. And on the right, confusion matrix, recall, precision, etc. What we would like to optimize for now is the precision. Why the precision? It's because we are looking in the past for now. So we want to be sure that when we say to a clinician, okay, let's have a look to this patient in the past, he may have had a sepsis. We want to be sure that it's a sepsis because we want to save time for the clinician.
We say that, but I suspect they want to replace us.
Yeah. So here you have like the global overview of everything. Of course, we are putting in place different other things. We want to go to the prospective, hopefully very soon. We also have validation set where we try to see if the model is performant and why we choose an ensemble method, because as Sylvain said, using one model to predict sepsis for a pregnant woman or a 65-year-old man is completely different. It makes no sense. So the objective is to evaluate each model of the ensemble method and see how they perform and maybe to do prediction to the endotypes. And here's the team. So the project is a collaboration between the SHUV and the SDSC, and here you have all the people that are working on the project, and I would like to thank them all.